Hey class, today we're going to be talking about adding fractions and mixed numbers. Okay, that's going to be our title. Adding fractions and mixed numbers. Okay, this is what we're going to be doing. Okay, so that is your title. You should write that down. Now, the first thing I want to ask you is, again, I'm going to start off with a question, right? What do you have to have in order to add or subtract fractions? Okay, that's my question. What do you have to have in order to add or subtract fractions? What do you have to have? The answer is same denominator, or common denominator, right? Common denominator sometimes confuse some of us, right? So I'm going to go ahead and say same denominator. Okay? We have to have the same denominator in order to add or subtract any types of fractions, right? Any fractions, you got to have the same denominator. Okay? That's key. All right? So again, make sure you have this written down. That's very important for what we're about to do here in a second, okay? Which is add fractions and add mixed numbers, okay? So I'm going to go ahead and erase this. All right, so we're going to go through the steps that we have to take in order to add fractions and add mixed numbers. So step one. Step one, Texas method if necessary. That's key right there. If you have to do it, step one, Texas method. Okay? Step two, get same denominator. Okay? Get same denominator. And step three, add numerators, which we know the tops, right? The top numbers of the fractions. And keep denominators. Okay? Keep denominators, which we know this as the numbers on the bottoms. Bottom, right? Bottoms. So numerators, add the top numbers and keep the denominator the same. Okay? These are the three steps that we have to take in order to work out these problems, adding and subtracting. I'm sorry, not subtracting yet. We're going to get to subtracting. Adding fractions and adding mixed numbers. Okay, we're going to focus on those first. So here we go. Example one. Example one is 2 over 3 plus 1 over 12. Okay? This is our first example of adding fractions and adding mixed numbers. So Right now, we're just adding fractions. We don't have any mixed numbers. Remember, mixed numbers has a combination of whole numbers and fractions. Here, we just got fractions. So, step 1, Texas method is necessary. Step 1, it's not necessary. We don't have to do the Texas method. Step 2, get same denominators. Remember, that was the question at the beginning. What do we have to have in order to add these? Well, we have to have the same denominator, and we do not. So we got to get them somehow, and that's what we got to do first, okay? So, there's a way for us to look at this problem and say, okay, for this problem in particular, we want to do, they got something called the LCD, right? LCD, we can use the LCD. We got two ways of actually doing this. We have, again, I got different names for them. So one of them is easy now, hard later. Okay? Easy now, hard later. What I mean by that is that the easy way to do this is to just multiply 3 times 12, which is 36, and that's easy now. That means all I got to do is write 36 right here for my new denominator, right? We got to get the same denominator. And what we're doing here is we're creating those equivalent fractions, right? So whatever I do to the 3 to get the 36, I also have to do to this 2 up here, right? And so 3 times what will give me 36? Well, I know it's 12. And whatever I do to the bottom, I have to do to the top, right? So now I'm going to do, I did 12 times 3 to get this 36. Now I'm doing 12 times 2 to get this 24. And remember, we talked about those already, equivalent fractions. We just created an equivalent fraction. The equivalent fraction that we created was 24 over 36. This number is the exact same thing as 2 over 3 in decimal form. Remember, we did that together. 2/3 and 24 over 36, they have the same decimal value. They just look different, right? We talked about that with equivalent fractions. Now we got to create an equivalent fraction to 1 over 12. And we're going to do that using the same idea that we use here. Whatever we do at the bottom, we have to do at the top. How do I get 12 to be 36? I got to multiply it by what? By 3. Whatever I do at the bottom, I got to do to the top. 12 times 3, I get 36. 1 times 3, I get 3. Okay? Now, I created an equivalent fraction. That's how we get the same denominator. 2 over 3 became 24 over 36. 1 over 12 became 3 over 36. Now you can completely ignore this side, and now you're just working with this side. You have the same denominators, right? That's what our question was at the beginning. We have to have the same denominators. When we have the same denominator, then we go to step 3. Step 3 says add numerators. That's the top numbers. We're going to add those. 24 plus 3, we get 27. Keep the denominators. 36 stays the same. Now, are we done here? No, right? Always and forever reduce. From now on, never ask me if you have to reduce. Always. You always have to reduce. What can we reduce 27 and 36 by? We'll go into both of those. What number will divide those evenly? 27 and 36? 9, right? So we're going to go ahead and divide the top by 9. And this is actually the hard later. So easy now means I have to multiply these to get this. Hard later means I got to figure out now what I'm going to reduce this by. We figured it out to be 9. 36 divided by 9, we get 4. 27 divided by 9, we get 3. So our answer ends up being 3 over 4. All right, so we're going to go ahead and stop it here, and we're going to continue on part 2 on the next video. Thanks for watching, guys.